Hello students, today we are going to see NCERT exercise 8.1 of sequences and series. A small disclaimer: the images, text and other materials used in our presentations are for educational purposes only. We respect the intellectual property rights of the original creators and owners. If you are the owner and have any concerns or issues, please contact us at SATHEE@itk.ac.in and we shall remove the content immediately. Please note that the parts of the content may have been generated using generative AI, which is an experimental. Here's our question. Simple question. What you have to do is write a 5 first terms of your sequence where nth term is given by this rule, n times n plus 2. Just substitute your n, meaning position, and you will get your output, the nth term. Solution. Substituting n1, 2, 3, 4, 5 will give me first 5 terms of my sequence. So for n1, substituting 1 here and here, will get 1 times 1 plus 2, which is 3. So first term of your sequence is 3. Now second term, 2 times 2 plus 2, 2 times 2 plus 2, which gives me 2 times 4. So second term is 8. Third term, 3 times 3 plus 2. So 3 plus 2 is 5. So 3 times 5 is 15. So third term of my sequence is 15. A4, meaning fourth position term. 4 times 4 plus 2, meaning 4 times 6, which is 26. Sorry, 24. So A4 is simply 24. And fifth position term is 5 times 5 plus 2, meaning 5 times 7, 35. So fifth term is 35. So the required terms, first 5 terms, 3, 8, 15, 24, 35. Simple question. I hope the explanation is clear. Moving to next. Now this question. Again, write first 5 terms of your given sequence where an, meaning nth position term, is given by this rule, n by n plus 1. Just substitute your n values, first 5 n values, meaning 1, 2, 3, 4, 5, in order to get the first 5 terms of your given sequence. Solution. Substituting n1, 2, 3, 4 and 5, we are going to have, so for n1, a1 meaning first position term is simply 1 divided by 1 plus 1. We are getting 1 by 2 as our first term of my sequence. Now a2 represents second term of my sequence, which is given by 2 by 2 plus 1. So second term is going to be 2 by 3. For third term, simply 3 by 3 plus 1. So third term is 3 by 4. Fourth term, A4, is simply 4 by 4 plus 1, meaning 4 by 5. So fourth term is 4 by 5. Fifth term is simply 5 by 5 plus 1, which is 5 by 6. So fifth term is 5 by 6. Therefore, the required first 5 terms of my given sequence is simply half, 2 by third, 3 by fourth, 4 by fifth, and 5 by sixth. I hope the explanation is clear. Moving to next. This question. Again, write a first 5 terms of your given sequence. Sequence nth term is simply given by an, which is equals to, defined by this rule, 2 raised to the power n. Solution. In order to get first 5 terms of your sequence, just substitute n1, 2, 3, 4, 5 into this rule to get the nth position term. So for first position a1, we are going to have the term 2 raised to power 1, which is 2. So first term is 2. For second term a2, we are going to have 2 square. So second term is 4. Third term is 2 cube, which is 8. 2 times 2 times 2, which is 8. So third term is 8. A4, 2 raised to power 4, meaning 16. 4 times 4, 16. So fourth term is 16. Now A5 represents the fifth term of my sequence, which is given by 2 raised to power 5, which is 32. Therefore, the required terms are 2, 4, 8, 16 and 32. I hope the explanation is clear. Moving to next. This question. Here we have to find the indicated terms whose nth term is simply defined by this rule, 2n minus 3 by 6. What are our indicated terms? So, solution. So, substituting 1, 2, 3, 4, 5 n values, we obtain a1 as 2 times 1 minus 3 by 6, which is equals to minus 1 by 6. Simple. So first term is going to be minus 1 by 6. A2, 2 times 2 minus 3 by 6, which is 1 by 6. So second term is 1 by 6. A3, 2 times 3 minus 3 by 6, which is half. So third term of my sequence is half. A4, 2 times 4 minus 3 by 6, which is 5 by 6. So fourth term is 5 by 6. A5, which is 2 times 5 minus 3 by 6, which is 7 by 6. So fifth term is 7 by 6. So in this case, we are having first 5 terms, 1 by minus 1 by 6, 1 by 6, half, 5 by 6 and 7 by 6. I hope the explanation is clear. Moving to next. Now, in this, we are given with this rule, an represents your nth position term of your sequence, given by minus 1 raised to power n minus 1 times 5 raised to power n plus 1. Solution. So just substitute in order to get the first 5 terms n values as 1, 2, 3, 4, 5. So for first term, we are going to have minus 1 raised to power 1 minus 1 times 5 raised to power 1 plus 1. This gives me 5 square, which is 25. So the first term of my sequence is 25. Now second term of my sequence is minus 1 raised to power 2 minus 1 times 5 raised to power 2 plus 1. This becomes minus 1 raised to power 2 minus 1 becomes minus 1. And 5 raised to power 2 plus 1 becomes 5 cube. So we are having minus of 5 cube, and 5 cube is 125. So I'm getting my second term of the given sequence as minus 125. Now the third term, simply given by using the rule minus 1 raised to power 3 minus 1 times 5 raised to power 3 plus 1. Minus 1 raised to power 3 minus 1 becomes 1, and 5 raised to power 3 plus 1 becomes 5 raised to power 4. And this 5 raised to power 4 is nothing but 625. So my third term of the given sequence is 625. Now the fourth term given by this expression minus 1 raised to power 4 minus 1 times 5 raised to power 4 plus 1. This minus 1 raised to power 4 minus 1 becomes minus 1, and 5 raised to power 4 plus 1 becomes 5 raised to power 5. So just simplify minus 5 raised to power 5. We'll get minus of 3125 as our fourth term. Now for fifth, minus 1 raised to power 5 minus 1 times 5 raised to power 5 plus 1, which is 5 raised to power 6. If you solve this, you will get 15,625 as your fifth term. Therefore, the required terms are 25 minus 125, 625 minus 3125 and 15,625. Simple. I hope the explanation is clear. Moving to next. This question. So nth rule is given to us, n times n square plus 5 by 4. Solution. So if you substitute n1, 2, 3, 4, 5, what we obtain? The first 5 terms. Let's see. So for first term, we are getting 1 times 1 square plus 5 by 4, which is 6 by 4, which is 3 by 2. Now for second term, 2 times 2 square plus 5 by 4. 2 square is 4. 4 plus 5, 9. So 9 by 4. 2 times 9 by 4. This gives me 9 by 2. So my second term is 9 by 2. Now third term, using the rule, 3 times 3 square plus 5 by 4. 3 square is 9. 9 plus 5 is 14. So 3 times 14 by 4. This gives me, you can cancel what? 2. So this will be 7, this will be 2. So 7 times 3 is 21. So I am getting my third term as 21 by 2. Now for fourth term, by rule, 4 times 4 square plus 5 by 4. This 4 square is 16. 16 plus 5 is 21. And this 4 will be cancelled. So we only left with 21. So 21 will be my fourth term. Now for fifth term, A5, using the rule, 5 times 5 square plus 5 by 4. 5 square is 25. So 25 plus 5 is 30. So 5 times 30 by 4. This will be simple, 75 by 2. So my fifth term is going to be 75 by 2. Therefore, the required terms are 3 by 2, 9 by 2, 21 by 2, 21 and 75 by 2. Simple. Moving to next. This question. In this, we have to find out nth, as we are given with nth position rule. So nth term is simply given by 4n minus 3. Find out these given terms A17 and A24. Solution. Substituting N17 in order to get the 17th term. A17, using the rule 4 times 17 minus 3, which is equals to 68 minus 3, which is equals to 65. Substituting N24, we are having A24 as 4 times 24 minus 3, which is 96 minus 3. So the 24th position is 93. I hope the explanation is clear. Moving to next. This question. As we are given with nth position rule, using this we can find nth position term, n square by 2 raised to the power n. Now in this case we have to find 7th position term. Solution. Substitute n7 to get the 7th position term. So a7 is simply 7 square by 2 raised to the power 7. 7 square is 49 and 2 raised to the power 7 is going to be 128. So my 7th term is simply 49 by 128. This question. Nth position rule here is minus 1 raised to the power n minus 1 times n cube. Using this I can find nth position term. In this I have to find 9th term. Solution. Just substitute n9. What we obtain? The 9th position term is simply minus 1 raised to the power 9 minus 1 times 9 cube, using the rule. This minus 1 raised to the power 9 minus 1 becomes 1 and 9 cube is nothing but 729. And this will be my 9th position term according to the rule. This question. Here nth rule is simply given by n times n minus 2 divided by n plus 3, which is, so I have to find 20th position term. Just simply put n20 in order to get the a20. Solution. Just substitute n20. We'll get a20, 20th position term. 20 times 20 minus 2 by 20 plus 3. So 20 times 18 by 23, which is 360 by 23. So 20th position term according to the rule is 360 by 23. I hope this is clear. Moving to next. This, the first term of your sequence is given to us 3, and we are given a rule in order to find nth term. So this is your recursive sequence. So nth term depends on the previous terms. So nth position term is simply 3 times the just previous term plus 2. So in this, find first 5 terms. Solution. So the first term already been given to us 3. Using the recursive relation an is equals to 3 times an minus 1 plus 2. So second term given by a2, which is 3 times a1 plus 2, which gives me 3 times 3. So a1 is already given to us 3. So 3 times 3 plus 2. 9 plus 2, 11. So second term of my sequence is 11. For third term a3, using this relation, I am going to have a3 is equals to 3 times a2 plus 2. a2 is 11. So 3 times 11 plus 2. 33 plus 2, 35. So third term of my sequence is 35. Now A4, fourth term, using the relation 3 times A3 plus 2. A3 is 35. So 3 times 35 plus 2 gives me 105 plus 2, meaning 107. So fourth term of my sequence is 107. Now A5, which is using the rule 3 times A4 plus 2. A4 is 107, which gives me 3 times 107 plus 2. So what is 3 times 107 plus 2? Simply, you will get, so you will get 323 as a fifth term. So the first 5 terms of your given sequence is simply 3, 11, 35, 107, 323. And the corresponding series. So if someone asks to find out their corresponding series, quite simple. You just have to add all these terms you have got. So 3 plus 11 plus 35 plus 107 plus 323 and so on. Simple. Moving to next. This question. Write the first 5 terms of the sequence as A1 is simply minus 1. An is An minus 1 by n, where n must be greater than equals to 2 in order to get the terms, second term, third term, fourth term, and so on. Use this rule. Solution. As the first term already given to us minus 1 and nth position rule is An minus 1 by n. So using the rule, the second term is simply A1 by 2, which is A1 is minus 1, so second term is minus half. Now A3. Using the rule, A3 is A2 by 3, which is A2 is simply minus half. So using the A2 value, we'll get A3, the third term, as minus 1 by 6. Now A4. A4 using the rule is A3 by 4. Now using this value A3 as minus 1 by 6, we'll get fourth term as minus 1 by 24. Now A5. Simply using the rule A4 by 4. So using the value of A4, which is minus 124, we'll get the fifth term as minus 120. Simple. I hope the explanation is clear. Moving to next. Hence, if so, our first 5 terms of the given sequence is simply minus 1, minus half, minus 1 by 6, minus 1 by 24, and minus 1 by 20. And if you have to write the corresponding series, it will be very simple. Just add all the terms you have got. So minus 1 plus minus half plus minus 1 by 6 plus minus 1 by 24 plus minus 120 plus so on. Simple. Moving to next. This question. Here, write the first 5 terms of the sequence. A1 and A2, first 2 terms are already given to us 2. And we are having recursive relation An is equals to An minus 1 minus 1 in order to get the other terms 3, 4, 5 and so on. Solution. A1, A2 already given to us 2. Using this recursive relation, we can find the remaining 3 terms. So A3 is simply A3 minus 1, which is A2 minus 1. So A2 is 2. So 2 minus 1 is 1. So A3 term is just 1. Fourth position term is simply using the rule A3 minus 1. A3 is 1. So fourth term simply be 1 minus 1, 0. So fourth term is 0. Now fifth term A4 minus 1. A4 is 0. So 0 minus 1 meaning minus 1. So fifth term is minus 1. Hence the first 5 terms of the given sequence 2, 2, 1, 0, minus 1. Also the corresponding series is simply 2 plus 2 plus 1 plus 0 minus 1 and so on. Clear? I hope the explanation is clear. Moving to next. Now, Fibonacci sequence is simply defined by, so in Fibonacci, we already have first 2 terms as 1. So A1, A2 both 1. And for upcoming terms, we define recursive relation. So an is equals to, so nth position term is simply given by adding just 2 previous terms, an minus 1 and an minus 2. Now using this, find an plus 1 divided by an for n values 1, 2, 3, 4, 5. Simple. Solution. So A1, A2 both 1, meaning first and second terms both 1. Recursive relation given to us. An or nth position term is simply given by an minus 1 plus an minus 2. So the third term is simply using the relation A2 plus A1. A2 and A1 both 1. So third term is simply 1 plus 1, which is 2. A4, just add 2 previous terms. So A3 plus A2. A3 is 2. A2 is 1. So 2 plus 1 is 3. So 3 is my fourth term. Now fifth term A5. Add just 2 previous term A4 and A3. A4 is 3. A3 is 2. So 3 plus 2 is 5. So fifth term of my Fibonacci sequence is 5. Now A6. Sixth term is simply add just 2 previous terms, A5 plus A4. A5 is 5, A4 is 3, so 5 plus 3 is 8. So sixth term of my Fibonacci sequence is 8. Now for n1, an plus 1 by an becomes a2 by a1. A2 is simply 1, a1 is also 1. So an plus 1 by an is equals to 1 for n1. For n2, an plus 1 by an becomes a3 by a2. a3 is 2, a2 is 1. So an plus 1 by an becomes 2 for n2. Now for n3, an plus 1 by an becomes a4 by a3. a4 is 3, a3 is 2. So an plus 1 by an becomes 3 by 2 for n3. For n4, an plus 1 by an becomes a5 by 4, which is simply 5 by 3. So for n4, an plus 1 by an becomes 5 by 3. For n5, an plus 1 by an becomes a6 by a5. a6 by a5 becomes 8 by 5 from the previous values. I hope the explanation is clear. So this is it from this session. Thank you.